Hello, Professor Todd Elliott here, and in this video we are looking at the Siglent SDS1104 digital oscilloscope, which is the one I have here at home, which I like very much, by the way. Anyway, what we're going to talk about today can be applied to any digital oscilloscope, just like all the controls in any brand or of car are a little different, but if you know one, you kind of know how to drive them all. And the same thing applies to the digital scope. So what I have here on the screen is from my function generator. I have a sine wave frequency of 10 kilohertz. Peak to peak voltage is 1 volt. So if I change the coupling, see where it says DC coupling? So that is, you have to choose the coupling method, and in almost all cases I recommend DC, but we'll get into that as we go along. Okay, so let's just change that, and whatever scope you have you're working on, it's going to be a little bit different where the controls are, but they're all the same. So if I set it to ground coupling, what that allows us to do is to establish the ground reference. And I'm just changing the position control for channel 1. And if you're using more than one channel, then you will need to do this individually. But you see how as I'm turning it, it displays the actual position of the ground line relative to the center line of the screen. Okay, so I'm just going to dial that to 0. And that will then establish our 0 reference, or our ground reference, to whatever your favorite term is, to be in the center of the screen. I like it there. Sometimes you do need to move it, but I do kind of like it there. And there we go. Okay, so it's right in the center. Okay, most oscilloscopes, if you hit the position control, it'll automatically put it in the center. But I like to do things manually. Yeah, I'm old, that's the way it is. Okay, so right now that's where our ground reference line is. It's not showing my sine wave from my generator because the input channel is not yet enabled. Okay, so if I change my input coupling, let's put it on AC. Now, because I have a sine wave set up and there's no DC offset to it, then the AC is going to come right through. Okay, and then now you can go into the measurement menu, and again, every scope is different how you access this, right? But I'll just cycle some through here. Okay, so let's see, base. Now on this one, top is like the top of the waveform, which is kind of like peak. The base is like minus peak. Some scopes identify this as plus Vmax and minus Vmax, but it's okay. Now, do you notice how there on the screen it gives you a little bit of a waveform image as I go from point to point? And that's really handy, how it shows you pictorially, and there's actually little help menus, and all decent scopes have this, is that it explains to you exactly what the measurement is, right? So that's really kind of cool. Okay, so let me go then, and because it's a sine wave, we'll have RMS. Okay, pick on that. You see how now it adds it down to the bottom. Okay, so I'm just gonna turn off the menu there, and then there we go. Okay, so now it just displays it on the bottom. All right. So there's your waveform. Now the time base, the horizontal. Okay, so notice how I change that. Now you see on the right hand side there. Okay, this is where my scope shows it. I have other videos on the right all scope, and it shows the vertical and horizontal settings down here. It doesn't matter. They're there. They're on the screen somewhere. They want you to find them. Okay, all right. But you can see then as I change my 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 time base, okay, it changes. It literally changes the sorry the setting there right on the screen. So that's 50 microseconds per division. So now I'm changing it to 200. I can see a lot of cycles and just a few cycles. Okay. Now, beginning students or hobbyists, when they first encounter this, it's very common to think that by changing the oscilloscope controls, you're affecting the waveform. And indeed, it looks like you are on the screen because it is changing, right? But it's not true, right? So the analogy I always like to use is if you go out with your camera and you take a picture of the mountain, the big tree, whatever it is, right? If you change the zoom, does the mountain move? Well, no, of course not, right? But your perspective changes. So it appears to shrink or grow in size. It's just changing the perspective, right? So the only way to alter the signal is to change the signal source itself. So nothing on the scope will change that. You're just changing how it looks, okay? All right, so I'm going to set that up to there. That's kind of a setting I like. Depending on the frequency, I like to see sort of 2 or 3, 4 cycles on the screen. I find that's just a convenient setting, but you know, you use whatever you want, okay? All right, now back for the vertical setting, okay? See how it's set to 200 millivolts per division, right? 100 millivolts per division. And of course, it's pushing it off the screen. Now, one thing with every digital scope that I've used, and albeit it's not a lot of them, but if you have the waveform either horizontally or vertically off the screen, so to speak, the auto measure feature, it'll eventually stop measuring because it wants to see it on the screen. Okay, so it's very important that you keep it on the screen centered. Okay? Now, so let's look at the trigger, and then we'll play with the coupling again. Okay, so the trigger setting, right? I'm adjusting that line. Now I have it set to auto trigger, and I like auto because auto means if there's a no signal on the screen, it'll show that ground reference line. Okay, so if I put it back to the ground reference line there, and if I take my my trigger setting from auto and I put it on normal, look, that ground reference line is turned off. So with the normal trigger, then if there's no input signal, then do not display anything on the screen. Okay, I don't like that setting. You might. Okay, I prefer auto. So if there's no signal coming in, display the ground reference line. That's how I like it. But you can use whatever you like, of course. Okay, so back to the AC input coupling. So now I'm moving the trigger arrow. Now you see that arrow, okay, and you see that line, and you see the number there. That is basically the point at which the oscilloscope is triggering on the channel. Now I only have one channel enabled at this point in time, so therefore I must trigger in channel 1. If I bring a separate input source into channel 2, okay, and I leave my trigger on channel 1, then the waveform. Well, let's just go ahead and do that, and you're going to see what happens. Okay, so look up here on the screen. Okay, so if I go here to my trigger setup, okay, again, how you access that is different on every scope. See where it says source? Okay, I'm going to have to turn on channel 2 in order to get that to show up. Okay, and then sorry, I have to go back to setup there. Okay, if I go to channel 2, and voila, channel 1 is auto triggering. Sir, the waveform is moving, make it stop. Okay, and then they come along and just adjust the trigger line, and sir, that's like magic. No. You're telling the oscilloscope to trigger on the signal coming into channel 2, and there is no signal on channel 2. It can't trigger, so the waveform travels. Okay, so no problem. So I'm going to put the trigger source back to channel 1. Boop, there you go. The waveform's all nice and steady, right? I'm going to turn off channel 2, so we just see back our channel 1. So keep that arrow on this on the waveform somewhere. Now look what happens if I just go off there, like there, off the top peak. It's going to stop the trigger, right? It's traveling. I'm back touching the waveform. That number in the middle, that volts, right? That's its position relative to the true midline, center line of the screen. So now I'm just below. Okay, I'm going to dial it all the way down so it's off the waveform. It's not traveling again. So it's got to be, what I will say, touching the waveform, okay? Right? Now, let's say I change the volts per division setting, right? And I'm going to make it small. Look, it's not triggering anymore. So in that case, then, right, I'd have to would adjust it down a little more. And I got it, the volt setting so small, it's going to be hard to find that trigger point. So there's always a balance point, right, to where it'll trigger easily and to have a nice size waveform on the screen, okay? So that line, that arrow, it's got to be, must be at all times touching the waveform, okay? Now, I'm going to go in on my function generator, which, by the way, no particular reason you need to know this, but hey, it's my video. It's a Unity UTG962E 60 megahertz. And these are technical waveform generators now, so they're kind of programmable. Hey, like, welcome to the new world, right? So this one allows you to put in a DC offset. So a normal sine wave is, there's no offset, it's biased around 0, okay? So I'm going to enable an offset here, and look what happens. The wave, right? All right, so right now I have a 4-volt offset dialed into my waveform, but the waveform appears as centered around the screen. That's because we used AC coupling. Okay? Basic capacitor theory says a capacitor under DC will charge and then it will stop. Okay? And once it stops charging, it blocks DC. So if we want to see that bias voltage, right, which is the DC offset, we need to move the coupling over to DC. Look, it's off the screen, right? Because the volts per setting I have, division setting I have. So let's change it down. And look, now it's way off. My trigger's off. Everything is all messed up, okay? But that's okay. We'll get it. We will get it reestablished. Okay? And because of where I have the 0, all right, it's very, and with the amount of offset that I have, it's very, very hard to find that trigger point and to have it, try it one more time here. No, so the way I have it set up, now what I would really need to do is to move the ground line down to the center, and then so I can use a lower volts per division setting to give the waveform bigger on the screen so the trigger can grab it. I'm not going to do that. I'm just going to reduce the trigger, okay, because right now the offset is 4 volts, the amplitude is 1 volt. So it's a big offset for such a little small signal. So I'm just going to turn that down to bring everything down closer to the center. And now I'll move my trigger arrow back down and there. Okay, and now I can change my vertical setting like there. And that should allow us to have something, hopefully. Nope, it's still not triggering. Still can't get it quite. Might still have too much offset. All right, so what I'm gonna have to do then is to get it to see it on the screen fully with those numbers, is I'm gonna move the coupling back to ground. Okay, and I'm gonna lower. It doesn't really matter where this is as long as you know where it is. Okay, so I'm gonna move it all the way down. Okay, to, I don't know, maybe there somewhere, and now just allow me to use a lower volts per division setting just to get it on the screen. Okay, there. Okay, so you manipulate the controls around, but remember, when you're touching the oscilloscope, you're not touching the waveform, you're just moving it around on the screen to make it more convenient to measure. Okay, so you can see now you have that nice DC offset, and again, right? If I go back to AC, it's going to be gone, right? Now on AC coupling, right, it'll be biased around wherever the ground line is that you set. Of course, we had to just move it, so we're going to then just shift it back up then to the center, okay, like there. So now it's a beautifully centered waveform, okay. So as far as the coupling goes, there's really, in my experience, no real reason to use AC coupling. If you got a sine wave and there's no DC offset, or you get a sine wave and there is an offset and you don't want to see it, fine, go ahead. Otherwise, use the DC coupling, because what you actually see on the screen is really what you have, okay? And I'm just going to decrease that offset just to bring it down there so it's nicely centered on the screen, okay? So there'll be more videos coming soon enough, but hope this was helpful. Enjoy, and God bless. Bye.